January 2026 doesn't begin with drama. It begins like any other morning, routine, predictable, controlled. Then, within minutes, everything fractures. A massive sewer interceptor near a major U.S. city gives way, and what follows is not a contained incident, but a cascading failure. Hundreds of millions of gallons of untreated waste surge into a river system that millions depend on. Within days, bacterial levels skyrocket to catastrophic levels. Water, something so basic it's taken for granted, becomes dangerous. This isn't just a story about one failure. It's a warning. Because beneath the surface of modern life lies a fragile truth. Our water systems depend on constant pressure, uninterrupted electricity, and aging infrastructure that is quietly deteriorating. When one piece fails, the entire system can unravel in real time. Now here's where it gets uncomfortable. 2,000 years ago, the engineers of ancient Rome solved this exact problem without electricity, without chemicals, and without pumps. They built water systems that not only supplied entire cities, but purified water continuously using nothing more than gravity and intelligent design. And parts of those systems are still working today. This isn't nostalgia. This is a rediscovery. Because buried in Roman engineering is a method so practical, so resilient, that modern engineers are beginning to revisit it. And more importantly, it's something you can apply yourself when systems fail. By the end of this, you'll understand not just how the Romans purified water, but how their methods can be adapted into real-world survival strategies today. We tend to believe that technological advancement automatically means superiority. But history and current events keep challenging that assumption. Across multiple cities, water systems built in the mid-20th century are failing at an accelerating rate. Pipes corrode, pressure systems rupture, entire communities are left with contaminated or unusable water for weeks. The issue isn't just aging materials, it's philosophy. Modern systems rely on force, pushing water across vast distances using pumps powered by electricity. This creates efficiency, but also vulnerability. When pressure systems fail, they fail violently. When power grids go down, water stops moving. Roman engineers approached the problem differently. They didn't try to overpower nature. They worked with it. Their aqueducts relied entirely on gravity, carefully calibrated slopes, and controlled flow. Instead of forcing water through pipes, they guided it gently over long distances. At its peak, Rome delivered hundreds of millions of gallons of water daily to a population exceeding 1 million. And they did it using nothing more than elevation, patience, and precision. Their systems didn't depend on constant energy input, which meant they didn't collapse when external conditions changed. That distinction between forcing and guiding is the foundation of everything that follows. At the core of Roman water purification was a structure known as the Piscina Maria. On the surface, it looked simple, just a basin integrated into the aqueduct system. But in reality, it was a highly refined purification device. As water flowed through narrow channels, it carried sediment, sand, silt, debris. When that same water entered a wider chamber, its velocity dropped dramatically. This reduction in speed triggered a natural process. Heavier particles settled to the bottom. The Romans didn't need modern fluid dynamics to understand this. They observed it, refined it, and scaled it. These settling tanks were strategically placed along aqueduct routes. Some systems used multiple chambers in sequence, forcing water to pass through several stages of sedimentation. Each stage removed finer particles, producing increasingly clearer water. Design details mattered. Water entered from above to avoid disturbing settled material. Outlets were positioned midway up the chamber, ensuring that neither surface scum nor bottom sludge continued downstream. Maintenance was built into the system, allowing sections to be cleaned without disrupting the entire flow. What appears basic is actually precision engineering. It's a passive system that uses time, gravity, and space to achieve purification. No moving parts, no energy input, no chemicals. Settling alone doesn't solve everything. Clear water can still contain harmful substances. The Romans addressed this with filtration methods that mirror modern techniques. Archaeological findings across the Mediterranean reveal the use of charcoal in water systems. Crushed charcoal acted as an early form of carbon filtration, absorbing impurities and improving taste. This wasn't accidental. It was deliberate, based on generations of observation. In other regions, Engineers incorporated sand filtration. Water was directed through layers of fine sand, trapping particles too small to settle. Over time, a biological layer formed on the sand surface, a living filter that consumed harmful microorganisms. Today, this is known as biological sand filtration. It's used in modern water treatment systems worldwide. The Romans were using it nearly 2 millennia ago. They also introduced aeration through vertical shafts along aqueduct routes. As water interacted with air, it underwent natural oxidation. This improved taste and reduced harmful anaerobic bacteria. Taken together, these methods form a complete system: sedimentation, filtration, biological treatment, and aeration. It's essentially a full water treatment process, executed without modern science, yet fully aligned with it. A purification system is only as durable as the structure that contains it. This is where Roman engineering becomes even more remarkable. Structures like the Ponte d'O Guard still stand today, nearly 2,000 years after their construction. The Aqua Virgo continues to supply water to the Trevi Fountain. Secret lies in Roman concrete. It's unlike modern concrete, which deteriorates over time. Roman concrete has self-healing properties. When cracks form and water enters, chemical reactions trigger the formation of new mineral crystals that seal the cracks. In modern infrastructure, water is the enemy. In Roman construction, water was part of the solution. This durability wasn't accidental. It was the result of material choices, temperature control during mixing, and an understanding of how structures interact with their environment over time. Water in Rome wasn't just a resource, it was control. Access was regulated and systems were closely guarded. Officials oversaw distribution, and unauthorized tapping of aqueducts was treated as a serious offense. But the collapse of the Roman Empire disrupted more than governance. It dismantled the knowledge systems that sustained these technologies. During conflicts like the Gothic War, aqueducts were deliberately destroyed to weaken cities. Without centralized authority or trained engineers, maintenance ceased. Systems fell into disrepair. Over time, the knowledge behind them faded. What followed was a regression. For centuries, much of Europe relied on contaminated water sources, leading to widespread disease, problems Rome had already solved. This isn't just history. It's practical knowledge. A simple, gravity-based filtration system can be built using the same principles. A container becomes your structure. At the bottom, a drainage outlet allows filtered water to exit. Above that, layers are added: gravel for support, charcoal for absorption, and sand for filtration. Water is introduced gently at the top. It moves downward through each layer. Sediment is trapped. Impurities are absorbed. Microorganisms are reduced through biological activity. The result is water that is significantly cleaner. In a survival situation, it should still be boiled before drinking. But the transformation from contaminated to usable is immediate and critical. This is not theory. It's a proven system that sustained one of the largest cities in the ancient world. In cities facing flooding and infrastructure strain, engineers are reintroducing passive systems. Constructed wetlands, for example, slow water flow, allowing natural processes to filter contaminants. These systems don't rely on pressure or constant energy. They distribute water across wider areas, encouraging sedimentation and biological filtration, exactly what Roman engineers designed centuries ago. This shift reflects a broader realization. Complexity isn't always strength. Sometimes resilience comes from simplicity. Roman water systems endured because they aligned with natural processes. They slowed water down. They allowed it to settle. They created space for purification to occur naturally. Modern systems often do the opposite. They accelerate, compress, and force. As infrastructure ages and environmental pressures increase, the question becomes unavoidable. Are we truly advancing, or are we rediscovering what we once understood? The Roman approach offers more than a historical insight. It provides a framework for resilience, one that can be applied at both the city level and the individual level. If this breakdown gave you a new perspective on survival and ancient engineering, share your thoughts below. And if you want more deep dives into the practical genius of the past, subscribe to Intelligent Survival. Share this with someone who needs to understand how fragile modern systems really are, and how powerful ancient solutions can still be.